Our next question looks at lichen on a rock. A scientist wants to find the area covered by lichen. She measures the distance across the area of the lichen, you can see that on the question, and records it as 24 centimetres. She then estimates the area using this calculation, 3 times 12 squared, giving her 432. Now, the 12 is simple enough. The 12 here is half of this 24. And so we can think probably what they're doing here is modelling it as some sort of circle where 12 is our radius. The scientist has approximated the value of pi by rounding it to 3. So you can see what we've got is pi times the radius squared. So indeed it is a circle. Now the value of pi itself, if we check that on our calculator, is actually 3.141592654, and so on. It goes on forever, although the calculator's given up. So 3 is an underestimate, so she's multiplying 144 by a smaller number than it should, and therefore the overall result will be smaller. So this is an underestimate. That's all you'd need to write, but I would just explain because 3 is less than pi. Write down an assumption the scientist made about the shape of the lichen. Explain how this may have affected her estimate, and 2 marks, so 1 for each of those parts. So as we said earlier, she has assumed it is a circle, to use pi r squared. Assumed it is a circle. And explain how this might have affected her estimate. Well, the moss isn't a perfect circle. So if there are extra bits, it would be an underestimate. Or if there are chunks cut out of the circle, it would be an overestimate. Now this is one of those things in the mark scheme that it's just going to say any reasonable comment. So what I'm saying here is it could be an over or an underestimate depending on if the circle contains all of the lichen and there's more outside, or it would be an overestimate if the circle contains all of the lichen and there are also some bits without lichen inside the circle. But any reasonable comment will do. Question 10, given that a is an even number, prove that a squared is an even number. So, in order to make a an even number, I'm going to say a is equal to 2n, where n is an integer. What I'm saying there is that I take an integer, I multiply it by 2, I'll always have an even number. And therefore a squared is 2n all squared, which is 4n squared. And I need to show that that is always even. Well, I do that by taking out a factor of 2. If something is an integer multiplied by 2, it must be even. So I have shown that if a is an even number, 2n, where n is an integer, then a squared will be 4n squared, which itself is a multiple of 2, and so we have an even number. Part B, Eleanor says that if p and q are whole numbers, then p times q plus 1 all squared will always be odd. Find the values of p and q to show that Eleanor is wrong. Well, if I think about my square numbers, because I'm taking something I'm squaring here, I have 1, well that's odd, and then I have 4, well that's even. So if I could make pq plus 1 equal to 2, that would be good, but as p and q have to be whole numbers, that's not going to work for me. Then I've got 9, well that's odd, so that's fine. Then I've got 16, so if I can make pq plus 1 equal 4, then I will have disproved her result, because pq plus 1 all squared would be 16. And this occurs, for example, when p is equal to 3 and q is equal to 1. So I have an example there where pq plus 1 all squared is always odd. And then it says if pq plus 1 squared is even, what can you say about the numbers p and q? You must justify your answer. Well, pq plus 1 all squared is even. Well, 2 even numbers multiplied together, 2 times 2, will give me an even number, 4. 2 odd numbers multiplied together, 3 times 3 or 3 times 5, 9 and 15, give me an odd number. And 1 even and 1 odd number can't happen here because I'm squaring. So I can either have even times even or odd times odd. So if pq plus 1 all squared is even, then pq plus 1 must also be even. And therefore pq must be odd, because an odd number plus 1 will always be even. And how do I get a product of 2 whole numbers to be odd? Well, I can either do odd times odd, 3 times 1 is odd, I can do even times even, 2 times 2 is 4, that's even, or I can do even times odd, 2 times 1 is also even. So P and Q must both be odd in order for the product of PQ to be odd, so the PQ plus 1 to be even, and so that squared to also be even. I could also think of that just in terms of if either P or Q have a factor of 2, then P times Q must also have a factor of 2, so must be even. So both P and Q have to be odd for their product to also be odd. And that's a slightly unusual question, but quite a nice way to explore proofs and disproofs. And that's the next few questions sorted.